Hey pre-calculus, this is Mr. Aiden, and we're going to be doing 3 straight videos in a row on continuity, on whether functions are continuous or not, how do we make them continuous, all those, what are the different types of continuity. And so today we're going to be talking about types of discontinuity. And well, first we got to define what continuity is. You can see I have an art picture on the left and an art picture on the right, and there's two main differences in these two art pictures. The picture on the left is a horse where the person has never picked up their pencil. Their pencil has, it's called a continuous art. They've continued to draw this picture with never being able to pick up their pencil. But you can see the picture on the right, we've had to pick up our pencil over and over and over and over and over again, which means this picture is not continuous. It has many types of discontinuities. And so in calculus, we have the same thing. And so what we have to take a look at is first of all, what's our definition for continuity? And so this might be a little bit complex right off the bat, but it's really pretty easy. There has to be 3 conditions. First of all, f of x, that function must exist. That's got to be condition number 1. Number 2 is that the limit as x approaches some value c of that function must exist, which means you have to have those points meeting up on the limit from the left side, a limit from the right side, and so the limit must exist. And last of all, the main condition is the limit as x approaches c of your function has to equal that point of f of c. That defined point of f of c has to equal the existing limit as x approaches c. And so all 3 have to be true. So let's take a look at each one of these guys. There's 3 main types of discontinuities. We're going to define all of them. The first one is this one up in the upper left-hand corner. You can see if I trace my pencil along this function, it is continuous, 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 and guess what happens right here? We have a hole. We literally would have to pick up our pencil, put our point right here, and then bring our pencil back, which means this is discontinuous. And we call this a point discontinuity or a removable discontinuity. A removable discontinuity. Okay? So, because think about it. Do we have a limit as x approaches c? So we're going to call this 1 point c. The limit as x approaches c of our function of x, okay, as it approaches c from the left-hand side, we're approaching 4, aren't we? The limit as x approaches c from the right-hand side of our function is also equal to 4. But do you see, and we know f of 1, or f of c, we'll say, is equal to f of c is equal to 2, isn't it? So you can see our limit exists. The limit as x approaches c is equal to 4 because it was 4 from the left, 4 from the right, so it's 4 overall. But do you see how the point at 2 does not equal this 4, and so that means it is what we call a removable discontinuity. Okay, let's take a look at our second problem, which is this problem right in the middle. Okay, and I'll do this in a different color. I'll do this in orange, and you can see my pencil is going all the way this way right here, and you can see the limit, and again, I'm going to call this c, this point value 2. The limit as x approaches c from the left of this function is equal to 3. And the limit as x approaches c from the right, as we're going this way, you can see, of this function is equal to 2, which means does the limit exist? The limit as x approaches c does not exist. Why not? Because 2 and 3 are not the same value. They don't meet up. And so right away, condition 2 is not working here. We know f of c is equal to 3 because you can see I have a point right here at 3, but we have this not happening. And so we call this where we have to jump from one spot to the next, we call that a jump discontinuity. So we had a removable discontinuity, that's where we have a hole and that point is removed. we have a jump discontinuity when one function has to jump to the other. And last but not least, we have a last function right here. And you can see as we approach here, my c value is going to be right here. And as we approach the limit as x approaches c from the left of my function, we're going to go closer to negative infinity. We're going down. As we go to the right, as the limit of x approaches c from the right of f of x, we're equaling positive infinity. You can see these are not bounded, which means the limit as x approaches c of this function overall does not exist because it is not bounded. It's not bounded. And so you can see another thing is f of c is undefined. Okay, we have an asymptote here, and of course we are going to call this guy an asymptotic or asymptote discontinuity. So we have three main types of discontinuity. We have a removable discontinuity, a jump discontinuity, and an asymptote discontinuity. Okay, and if you take a look right here, what type of discontinuity do we have right here? We have an asymptote discontinuity. Right here we have a hole, which means we call that a removable discontinuity. Right here you can see this function jumps up, so we call that a jump discontinuity. And then of course take a look right here. We have a continuous function. Why is this a continuous function? Because you can pick any point C right here. The limit exists, our point exists at f of c, and not only does the limit exist as x approaches c of f of x, but that limit is equal to that point at f of c. And so all three conditions exist, which means this is continuous. Hopefully that helped. This is types of discontinuities. We're going to be doing 2 other videos on continuity. Make sure you do your self-assessment on MrRating.com, and we'll continue this later. See you guys. Bye.